This video presentation is called Three Levels of Detail, and it goes into the three various levels of detail that we will see in our entity relationship diagrams as we're modeling data. I'm Dr. James M. Renaud at Shawnee State University, and I'd like to welcome you. Again, this video is about the three levels of detail commonly found in entity relationship diagrams. You can stop and think about models and the levels of detail within a model. Think about a model airplane. You can get a little plastic model airplane that's this big. It's pre-assembled. Maybe the propeller spins. It certainly won't fly, but it gives you a feel for what an airplane sort of looks like. You can go to the hobby store and buy a much more detailed model that would have 50 to 100 pieces that you would trim and glue together, and you could see how some of the parts of the airplane work together. You could see more of the wing detail, maybe see flaps move. So again, you're moving into more detail of the model. You could go to another hobby store and maybe buy a model airplane that would actually fly, of course, because that second one won't fly, but you could buy a model that flies. Now, does it look quite as realistic? No, because it has to be modified to actually fly, but you still get even a better understanding of an airplane by building and using that model. Airplane manufacturers even make large-scale mock-ups of airplanes to test them in wind tunnels and do all kinds of other things to them as they go through the models. And each time they create another model, the model becomes more and more detailed. We do the same thing when we're creating entity relationship diagrams. And the three levels of modeling within entity relationship diagrams are known as the subject area model, the logical data model, and the physical data model. And they really correspond very closely to the little model airplane of is it a plastic airplane this big? Is it a plastic airplane, this big that maybe could fly? Or is it an actual airplane that is actually how we built the airplane? In a subject area model, what we're trying to capture here is a conceptual view of the data. What we want are the really important entities and the really important attributes if we know them. But we're not going into the detail entities. We're not going into all of the gory, how to make it actually work. We may put in primary keys. We may define foreign keys if we know them at this point. But often at this point, we're just trying to grasp an understanding of the subject and the big relationships. You may have many-to-many relationships in a subject area model, but as we move into the more detailed models, we will eliminate those because those are difficult to actually implement in a relational database. Let's look at a subject area model. For this video, let's pretend, or let's use the case that we're creating an application for your company's IT or information systems department, and they want to create an inventory of computers that it manages and all of the applications that are loaded on all of those computers. Imagine if you had hundreds or even thousands of computers to manage with dozens of apps on each computer, how complex that relationship gets to be and how managing that with a database would be very helpful. So in a subject area model, looking at the problem from way up, looking at the problem from 10,000 feet, looking at the problem just in the subject of the problem, we have computers, and we know that every computer's got a little tag on it, so we know that's the ID for a computer. We know that computers have manufacturer model, gigabytes of memory, gigabytes of hard disk, maybe it's got a processor, maybe, but those are the kind of big things that we want to model about a computer. There may be more details that we want to model, like what kind of sound card, how much video memory, and all those kinds of things, but we're not worried about that yet because we're just trying to understand the subject of the problem. The other part of the subject are the applications. A computer has 0 or more applications loaded on it, and an application can be loaded on 0 or more computers. And for the application entity, we know that apps have names, apps have versions, apps have maybe a license grant. Maybe you can only use so many of them, or maybe it's an open source or not. Or an application might have a developer. Like, is it developed by Microsoft? Is it developed by Oracle? Is it developed in-house? So those are things we might want to know about an application. So you can see that in the subject area model, looking at it from way up high, just trying to understand the problem, we can see that we have a computer and we have an application and we have a many-to-many relationship. A computer can have many applications, an application can be on many computers. Once we get a subject area model and the client who you're developing the system for has validated it and says, yeah, you get the subject here, it's now time to move into the logical data model. The logical data model is more detailed than the subject area model. With this model, we should be able to store the data and answer the questions that needed to be asked by the client. So the client will say, I want a report that does this, or I want to find out this, or I want to know this. Well, can you do it with a logical data model? Then your logical data model is good and you understand the logic of the data. A logical data model should have primary keys defined for all the tables. A logical data model should have the foreign keys defined for all of the tables. An LDM also should not have any many-to-many relationships. So we should eliminate the many-to-many relationships in a logical data model. And if you see where there's some subtypes that you may need to create a subtype hierarchy, it'd be a good place to do it here. You don't need all of the gory details, all the detail tables, all the control tables, all of the code tables. All of that doesn't have to be done here for the LDM. But the special the big tables need to be here. And we're not worried about data types yet. We'll worry about data types as we actually start to build the database and as we're modeling the physical characteristics of the database in the PDM. So here is a possible logical data model for that IT department's application. You can see that we still have computer and application. We've added some attributes to it. We've identified the primary key of the computer is its tag number. We've also identified the primary key of the application as being the name of the application and the version, because maybe we have one user who has one version of an app on his computer and another user with a different version of the same named app on their computer. Notice that what we've done is we've created this table here in the middle called installation that contains the primary key of the computer number, tag number, as a foreign key. It contains the primary key of the application, the name and the version, as foreign keys. And then I concatenate all three of those together to create a concatenated primary key of tag number, app name, and app version. Notice that the installation also has additional information that we care about in installation, including when it was installed, who installed it, if it was there and was uninstalled, when was it uninstalled, and who uninstalled it. We've added other attributes to the computer also. For instance, what location, what building is it in, what room is it in, what employee was it assigned to, because that's important. If we get a service call from an employee saying, I need you to fix my desktop, well, we can go find that employee's desktop there in the computer table. And I've created an employee table. Now, I don't have a primary key. I probably should have underlined EEID, the employee ID, as the primary key there, but you can see there's a whole bunch of data about an employee there. I would also assume that on the installation table, installed by and uninstalled by would also be foreign keys to the employee table, because it was an employee that installed it or uninstalled the software. But again, we're just trying here to get a full understanding of the logical nature of the data. And I think right now this would be a decent, Not perfect, but a pretty good logical data model. Now let's continue going down the rabbit hole of detail, because the physical data model is even more detailed than the logical data model, and it represents how we're actually going to create the database and the database tables. Everything has to be on here. All of the primary keys, the foreign keys, the data types, everything has to be here. And this is what's used by programmers and data analysts to actually create their database tables and create their queries from. So it needs to include all the data types, all the tables, the keys, the foreign keys, the primary keys, the subtypes, and all of that need to be included here in the physical data model. These can get extremely complex very quickly. So that simple subject area model of two tables with a many-to-many relationship has become this monster. And stop and look at it. You still see computer application installation. They're still there. The primary keys are still there. Most of the attributes that we identified in our LDM are there. Notice that every attribute has been given a type, like a varchar, which is a variable character, or text, or integer, or date. Those are all there now. You can see that we also have a table called developer, so that Microsoft would have an entry in the developer table. Apple would have an entry in the developer table. And an application belongs to one developer, but a developer can have many applications. A building has many computers, but a computer is only in one building. A manufacturer has many computers, but a computer is only manufactured by one computer. And you can see all of these relationships as we have identified the relationships. Notice there's one relationship that's kind of unusual, and it's the bottom relationship here. And that would be the uninstalled relationship, because what happens if software has not been uninstalled? It's only been installed. So uninstalled would be null, because we haven't uninstalled it yet. So the uninstalled by employee number would be non-existent. So we would say this relationship is 0 or 1 to 0 or many. So an employee can uninstall 0 or more applications, and an installation can be uninstalled by 0 or 1 employees, because it might not be uninstalled yet. It's a little tricky, but I wanted to point that out. Now that we have seen the three levels of entity relationship diagrams, the subject area model, the logical data model, and the physical data model, let's just do another quick example of the three. Our recruiting department in our company wants to keep a database of people and all the jobs they've ever had with our company. That would be a nice thing to know, to be able to pull up an employee and see all the jobs they've had, or to pull up a job and see all of the employees that have possibly had that job over the years. That would be interesting. So a person can have 0 or more jobs over the years, and a job can be had by 0 or more persons over the years. We're also going to need to add dates to track when they were assigned to each of these jobs. But at the subject area model, like a little plastic model of an airplane, it doesn't have a real engine in it. But we've made note of it because we know we're going to have to add that soon. And the logical data model is where that starts coming in. So this would be a good logical data model to store that data. We've eliminated the many-to-many relationship between persons and jobs, and we now have an assignment. So a person is assigned a job, and a job is assigned to a person. So we create the assignment tables, and a person can have 0 or more assignments, but an assignment belongs to only one person. A job can have 0 or more assignments to it over the years, but an assignment, a specific instance of an assignment, belongs to one and only one job. We can, the primary key for, you see the foreign keys of the job table and the foreign key of the person table on the assignment table to implement the one-to-many relationships. And I chose, in this example, the person ID and the start date for the assignment. You might think, well, why don't you use the person ID and the job ID? Well, a person could have a job, leave it within the company, take another position, and then come back to that first position they had or come back to a position. So they might have a job more than one time by date. The one thing that's unique is that on a specific date, a person will only have one job. So that's why I concatenated the person ID and the start date. The end date may be null because what if a person currently has that job? Well, then they wouldn't have an end date, would they? So end date couldn't be used for the primary key. I guess you could have concatenated person ID, start date, and job ID, but that's more than really necessary. Or you could have assigned a surrogate key to the assignment table, assignment 1, assignment 2, assignment 3, and not concatenated the key. But you can see here is the example of a logical data model that will answer the client's questions and eliminate the many-to-many relationships, and we've now identified all of our keys. Here's the physical data model, and it actually looks just like the logical data model, except we've now added our various data types to go along with each of the attributes. Your client may say, well, our job IDs, are you a salesperson? Well, that would be a certain job ID. You're a manager of this. That would be a number. May use numbers for job IDs. They may use a string or a character field for a job ID. Those are things that you have to ask as you're collecting your analysis of the database, as you're analyzing the business situation before you can finish your model and before you can start building your database. You have to really understand the data types. And you can see the various data types that have been defined here for this second example of a physical data model. This concludes this presentation. Remember, this presentation is copyright 2019 by James M. Renault, PhD. You can contact me at jrenault@shawnee.edu. This work is licensed under a Creative Commons Attribution, Non-Commercial, Share-alike 4.0 International License, and thank you for watching.